All right, it says we're recording. If ever there was a day that you attended class, today is the day. So we're going to start on chapter 2, which is numerically summarizing data. So we're going to talk about the mean, the median, and the mode. So the mean is what we commonly think of as average. The median is what we refer to as the middle value. The formula that we're going to use is n plus 1 divided by 2. And I'm going to give you an example in here in just a minute. And then we've got the mode, which is the most common value. So I am going to pull up a little spreadsheet here, and we're going to, this is a true story. Let's say that it's a true story, but I'm going to use fake data. So the University of North Carolina wanted to know how much geography majors made. Geography majors salary when they graduated. Okay, so they have one person that makes $25,000, another person that makes $30,000, another person that makes $30,000, another person that makes $35,000. Oh, let's make it $40,000. And graduate number 5 makes $1.2 million. Okay. Now, this is a famous person. I'm going to throw this out here just for fun. Do you guys have any idea who major number 5 is? Who's a famous person?
That went to North Carolina?
University of North Carolina.
Michael Jordan?
Michael Jordan. That is correct. Have you been watching The Last Dance?
No, I have not. I have not seen any of it yet. I keep reading.
I haven't seen it either.
But I've just been.
I don't have cable. Yeah. I'm waiting for Netflix. It's supposed to come out July 19th on Netflix. I was looking that up yesterday because I'm tired of everybody talking about it. Another trivia question. Before Michael was a geography major, guess what his major was? Apparently this came up in The Last Dance because I read about it. It was math. Michael Jordan said he was a math major, but then he was missing too much class, so he changed his major to geography. So anyway, all right. So now, if I asked you to find the average salary in the past, what would you do?
Take the sum of all and divide by the subjects?
Right. So you'd take the sum of all 5 of these students here, and you would divide by 5. Okay? Now, so according to this, now rather than call this the average salary, I'm going to call this the mean salary. Okay? So according to this data set, the mean salary, or what you've always called the average salary, is $265,000. Do you think that is a good representation of what a geography major can make?
No.
No. Why not?
Because the person who makes the most money, Michael Jordan, is not even in the field that they're working in. So, and it's like way skewed.
Yeah, so we would definitely refer to Michael Jordan as an outlier, right? Okay. So yeah, so Michael Jordan skews all the data high, okay, in this case. So so this is what we've commonly referred to as the average. I would like not to use that word anymore because there are different ways you can figure out an average, okay? Another way to figure out the average is what we call the median. The median is what we refer to as the middle value. And the nice thing, and so the formula that we're going to use, as I mentioned earlier, was n plus 1 divided by 2, okay? And so if we talk about the middle value, now that's pretty easy. I've only got 5 pieces of data here, right? So if I'm using this formula n plus 1, so n is your sample size, n is, so in this case, 5 plus 1 is 6. 6 divided by 2 is 3. Of course, in this case, you have to sort your data, which we luckily have it sorted. So I'm going to go 1, 2, 3. And so in this case, my median would be $30,000, whatever that is. Okay. So when we compare the median to the mean, which one is the better value to represent what a quote-unquote average salary would be?
In this case, the median.
In this case, the median. Okay. We're also going to talk about the mode. Okay. Now, the mode is the most common value. Okay. So the most common, what is the most common value in this data set that we have?
30,000.
That would also be $30,000 because we've got 2 people that make 30,000, so that's the most common. So in this case, the median is, or excuse me, the mode is there. Now, so that was fairly easy. What I want to do is I'm going to insert another student, and we're going to make this one $40,000. Okay, let's talk about the mode. Oh, I need to fix my thing now because we have 6 students instead of 5. So the mean salary is now $227,500. I will just tell you this, if I could really make $227,500 as a geography major, I would change my major today. Okay, but clearly we can see Michael Jordan's still the outlier. Let's talk about the mode. What is the mode now?
Isn't it still 30,000?
We've got 2 modes. Okay, so it would be $30,000 and $40,000. Okay, and just for fun, let me erase both of these here. What's the mode now?
Would you have 4 of them?
I would just say you'd have no mode.
No mode.
Okay, so you can have no mode, you can have 1 mode, you can have more than 1 mode. Okay, so the funny thing that I will say about the mode is you will never see this again after this chapter because it's not a very useful thing, except for, I will say this, you remember last time we talked about the different types of graphs. By the way, Easton, are you at the UVU library?
Yes.
So apparently the library is not closed. You're not making everybody sick, are you?
I hope not. I'm keeping my distance from everybody.
Yeah. I just saw these people walking by, and then I'm like, hey, that kind of looks like the library. Okay, so last time when we talked about our histograms, and by the way, I hope you can remember that. What was the name of this kind of a graph?
Bimodal.
Bimodal.
Bimodal, okay? So if we were to draw this in here, you'd have a mode here, and you would have a second mode right there. Those would probably be your 2 most common values. And so that's why we call that bimodal, okay? So it's funny that we teach you the graph first before we teach you about the mode, but that's the way this book does it. So so that's kind of why we call it that. So all right, so now I've got this. Now the median is going to be a little bit different, okay? I left that one out here. So in this case, I have 6 pieces of data, and so 6 plus 1 is 7. 7 divided by 2 is 3.5, okay? So I can't really count the 3.5. I can go 1, 2, 3.5, okay? And so in this case, when you have, we usually like an odd number, okay? But in this case, what we're going to do is we're going to do the mean of those two values, which I have a feeling you guys can probably do in your head. Can you do that one in your head? What would be the mean of 30,000 and 40,000?
35,000.
35,000. Okay. So the median can be a little, so the interesting thing, the idea with the median is half make more and half make less, okay? So the interesting thing about this is, in this case, half make more than 35,000, half make less than 35,000. Nobody actually in this data set actually makes $35,000 a year. So that's kind of interesting. So this is actually not part of your data set, the 35,000 in this case, okay? So with this data set, your mean would be still $250,000, 227,500. Your median's 35,000, and you have two modes in this case, 30,000 and 40,000. Okay? Does that make sense? All right, now, one other thing that I know that I've seen people do is if you want to find the median, you can basically cross out the, I don't know how to cross these out. Maybe I can do it this way. Oh, let's try this. No, that didn't work. Anyway, that's fairly easy to do. So I'll just, never mind on that. But anyway, so do you have any questions about the mean, the median, or the mode? Okay, so those aren't too bad. All right. Now, if we were doing a class, if this were in a class, I would have you find the mean pulse rate for every member of the class. All right, so now let's talk. Did I not talk about the 5-number summary? Okay, probably should add a thing on here that talks about the 5-number. Okay. 5-number summary consists of 5 numbers. And the 5 numbers are the minimum, the maximum. Now I'm going to go in order. Q1, the median, Q3, and the maximum. Okay, so you'll need to remember this in your for the test on Friday. Okay, 5-number summary consists of those 5 numbers. Now, a lot of people, it's always the median. It's not the mean. A lot of people put the mean in there, so that's a mistake that people can do. All right, so let's say, for example, plus we don't even have a regular, how many people do we have in class today? I'm just curious. Oh, we've got a few more people. You guys are sneaking in and not letting me know. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 people here. That's normally what I would do is I would have you guys figure out your pulse rate or something, but here's what we're going to do. Let's get a big data set, and I'm just going to do some random numbers. Random numbers. And we're going to do ran between, say, 7 and, I'm going to make some big numbers, 100. Okay, so I'm going to make a bunch of numbers here, however many we've got. Oh, I shouldn't make that many. Tell you what I'm going to do. I'm going to erase all of these. Okay, so we've got here 19 numbers, which makes it nice. Now I'm going to make these. Okay, so the numbers won't change anymore. Okay, so I've got in here a bunch of numbers. So the first thing I want to do is I want to figure out, let's figure out the mean, the median, and the mode. So let's have, I'll put that over here. Yami, can you give me the mean of these numbers?
Yeah, I can add them up and then divide it by 19.
Some of these, and we're going to divide by 19. So the mean is 80.94. The median, can you give me the median? Oh, this is terrible. Everything's always in the way. Wes. Oh, no, I've already picked on Wes. Let's go with Seth. Can you give me the median? Seth.
I'm here, sorry.
Okay.
I'm just putting them.
So how do you find the median?
It's the middle, so you'd put them in order, and then you would just find the middle number. So there's
Okay.
20.
So it's lucky I'm using Excel because I can sort them. Okay.
Yeah, it'd be would it be 10? It would be, sorry. Oh, sorry, it'd be 11.
Okay, so we have to count. We've got 19 here, I believe, right? Just making sure. Yeah, 19. So 19 plus 1 is 20. 20 divided by 2 is 10. So I'm going to count down to the 10th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So my median in this case is what?
72.
72. And the mode, let's give somebody else the mode. How about Janae? Or Janie? Is it Janae or Janie? I can't remember.
It's Janie.
Janie, okay. Janie, what's the mode?
The mode is 106
106 because?
because it shows up the most.
Yeah, we got 3 106s right there. Okay, so that's definitely the most. Okay, so you can see your mean, your median, and your mode are very different in this data set. Okay. All right, now let's talk about the 5-number summary. Let's see who can remember that, or actually we'll start picking on people. How about Easton? Do you remember what the 5-number summary was? What are the numbers, the values that make those up?
So it was the minimum, Q1, the median, Q2, and the maximum.
Q3, actually.
Oh, Q3.
Yeah, Q3 and the maximum. Okay, very good. I just taught you that and you remembered that, so very good. So the minimum would be very easy, which is what?
12.
And the maximum would be?
147.
147. The median, we've already figured that out.
72.
72. Okay. Now, I didn't really tell you what Q1 and Q3 were. So you can think of the median as the 50th percentile. Okay. So Q1 is the 25th percentile. 25th percentile. And the Q3 is the 75th percentile. Okay. So one way to think of the 25th percentile, you can think of this as the median of the top half. And you can think of the 75th percentile as the median of the bottom half. Now this can get a little tricky because the question is, do I include the median? Now, there's lots of different answers. If you go on the internet, you're going to find out that there's different answers to these questions. And so I'm going to tell you what I'm going to pick as the right answer. And I'm going to say do whatever it takes to make the number odd. Okay, now, in this case, we know that 72, I'm going to highlight this here. We know that 72 is my median, right? Okay, so remember the formula for the median. Formula for the median is n plus 1 divided by 2. And we like odd numbers. Like in this case, we had 19. 19 is an odd number because 19 plus 1 is 20. 20 divided by 2 is 10. And you can count down to the 10th one. Okay. Now the question is, do I want to include the median? And so I say do whatever it takes to make the number odd. So if adding the median makes the number odd, use it. If not adding the median makes the number odd, then do that. So in this case, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So in this case, I'm going to exclude the median. Okay, because 9 is an odd number, and I like odd numbers when I'm doing the median. Okay. So 9 plus 1 is 10. 10 divided by 2 is 5. So I'm going to count down 1, 2, 3, 4, 5. Okay. So in this case, my 25th percentile is going to be the value 36. Okay. I'm going to do the same thing here. I'm going to exclude the median so that this gives me a nice number 9. 9 plus 1 is 10. 10 divided by 2 is 5. So I'm going to count down 1, 2, 3, 4, 5. So that would be the value of my 75th percentile, or quartile 3, which is the value 131. Okay. Now, does that make sense? Now, just for fun, I'm going to put in another number like 246, just for fun. Okay. Now, in this case, here, I'll tell you what I'm going to do. I'm going to copy my data set over here. And we're going to see what the differences are. Okay, just by adding a single value here. Okay, now I'm going to get rid of all my highlighting here in this case. Okay, so now I've got 20. So if I'm going to compare, so this is, we'll go pre and we'll go post here. Okay, now if I've got 20 in this case, 20 plus 1 is 21. 21 divided by 2 is 10.5. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5. Okay. So I'm going to use both of those numbers for my median now. Okay. Now, obviously, the minimum is going to stay the same. My maximum is going to be 246. My median is going to be the middle of 72 plus 106. I'm going to divide that by 2. So in this case, my median is 89. Okay. Now, the question is, do I include the median? Okay, so I'm using both of these numbers here. Now, the median's not part of my data set, is it? So this gives me 10, and then my median is 89. So in this case, I've got 10 plus my median. Now, my median's not actually a data point in here, right? But I'm going to use it to make the number odd. Okay, so 10 plus 1 is 11. 11 divided, excuse me. Yeah, 10 plus 1, no, 10 plus my median of 89 would be 11. So that would be 11 plus 1 is 12. 12 divided by 2 is 6. So I'm going to go 1, 2, 3, 4, 5, 6. Okay. So in this case, I'm going to include the median, which is actually not part of my data set, but it makes it odd. And so now my first quartile, Q1, is 39. And I'm going to do the sixth one here. So I'm going to count this as 1, 2, 3, 4, 5, 6. So this can get a little bit tricky. So my 75th percentile happens to be the same, 131. Okay, does that make sense?
I have a question.
Yes.
Is this how they'll want you to do it on the homework as well? Because like it's very like specific on which numbers you choose. There's only one answer, right answer. So
Have you already done the homework?
For chapter 2, no.
Oh. Kyle, you know what? That scares me because I haven't checked how the homework does it.
Yeah, because I don't want to like do it wrong and get knocked down for that.
And I haven't done the homework and I can't remember. That's a really, really good question. And I was hoping you would tell me if they did it differently.
Sorry, I don't know.
And I don't know the answer to that question. So tell you what, ask that when you do the homework, let me know on Friday if they do it differently. This is how I would like you to do it on the test, but I don't remember I can't remember how they do it in the homework. And it could be a different method. So
Would we still get marked down if we got those questions wrong because we were doing this method?
well, because you can retake a question, right? So
yeah,
you should
but it knocks you down in percentage every single time you retake a question. So you wouldn't get the
Okay.
same good grade.
Okay, let me know. I wish I knew the answer to that question, and I don't know. And I will figure out how to adjust your score if that's what happens. Okay. That was Allie that asked that question, right?
Yes.
I'm getting to know you guys' voices because your faces aren't on my screen. I can't know your faces. I'll know your voices better than your faces. All right. So really good question. If the book does a different method, let me know and I'll somehow figure out how to adjust your scores on the homework. Okay? Does that sound fair? I hope that's a yes. All right. Okay, so with this, we've got the 5-number summary. Okay? So I've done it with 2 different data sets, and you can see the answers are slightly different on whether to include the median or not. So it can be a little tricky. All right, let me go back to my notes here. Okay, so now we need to go to the interquartile range, okay? So the interquartile range, the formula for that is Q3 minus Q1, okay? So as we look at this, it's going to be 131 minus the 36 in this case, which is 95. And in this case over here, it's going to be 131 minus 39, which is 92. Okay, so that's fairly easy. Now, the interquartile range, sometimes that's abbreviated IQR, interquartile range, is going to be very helpful for finding outliers. Okay. Now, to find outliers, you need to find a lower fence and you need to find an upper fence. Okay. Now the formula for this is the lower fence equals, sign here, lower fence is going to equal Q1 minus 1.5 times your interquartile range, IQR. And your upper fence is going to be Q3 plus 1.5 times your interquartile range. You're probably wondering why that 1.5 is in there, and I will tell you in a minute why that's in there. Okay. All right. So if we're figuring out our fences now, the idea here is, in fact, let me go back here for a moment. We're going to go back to Michael Jordan thing. Now we know that it's obvious Michael Jordan is an outlier in this data set. Okay. And in fact, what I'm going to do is I'm going to erase this one here so that the minimum, this is the minimum, this is your Q1, this is your Q2 or their median. I didn't tell you that, but that's what that is. This is your Q3, and this is your maximum in this case. Now we think Michael Jordan is an outlier, and he clearly will be. So if we were to figure out our interquartile range, let's see who can answer that question. Bridger, can you tell me what is the interquartile range for this data set here? Are you there, Bridger? Bridger shows up and then never talks. We need you to talk, Bridger. We want to make sure you're understanding things. So you need to turn yourself off mute. Okay, Allie, can you do that one? What's your interquartile range for this?
Well, it's Q3 minus Q1, right?
Correct.
So it'd be 10,000.
$10,000, right? Okay. Now the idea here is, maybe I should actually, well, we're looking to figure out your fences. We've got upper fence or lower fence, and we've got an upper fence. Okay, so Elise, can you give me what the, so the idea is the fences are going to help us decide if something is an outlier, okay? So, so this is Q1 minus 1.5 times your interquartile range, and this is Q3 plus 1.5 times your interquartile range. So can you tell me what those values are, Elise?
Yeah, so we're gonna get 30,000 minus 1.5 times 10,000.
Okay. So the idea here is what we're trying to decide is, are there any outliers on the lower fence? Okay. Does anybody in this data set make less than $15,000 a year? I'll open that for anybody.
No.
No. So we have no lower outliers. Okay. Now we're going to do the same thing. And Yami, can you help me figure out the upper fence?
Sure, it's gonna be 40,000 plus 1.5 times 10,000.
Okay, so what we're going to say in this case is that anybody who makes more than $55,000 a year is going to be an outlier. So does anybody make more than $55,000 a year?
Yes.
Yes. And that person is? Who makes more than $55,000 a year?
Michael Jordan.
Michael Jordan. Okay, so we're going to say, so we've officially calculated, we're not just guessing now that Michael Jordan is an outlier. So $1,200,000 is an outlier. That's your outlier, okay? Now, the idea here is, this is where I really wish we were using a computer here. But I'm going to have you guys hand draw these. Now, the important thing to do, I will show you this really quickly. Excel does have we're going to call this a box and whisker chart. So I'm going to show you what this looks like really quickly. And these can be, oh, that's interesting. They don't show Michael as an outlier. Oh, well, no wonder we don't want to do that. Anyway, that didn't work. So if I were to make this, the idea here is, I think I'm going to hand draw this in over here, okay? I'm going to kill this. I don't need this anymore. Now, what I would do in this case, this is going to be really, this is really bad data set for this. But the idea here is I'm gonna be putting some values here. So I've got 10K. What's my minimum value? Oh, my minimum is 25K. So 25,000. I'm gonna put 25K. I need to make this bigger. 30,000, 35,000, 40,000, 45,000, 50,000, 55,000. Okay, I'm going to stop there for a minute. Okay, so first of all, you need to have some sort of a scale on here, okay? Now, the idea here is, if I'm going to draw this, okay, so my first quartile, this is really a bad data set. You know what, I'm going to go to this one. This is going to be easier to do. So never mind that. That's kind of a silly data set. We're going to do a random, we're going to do a box and whisker on this, okay? Actually, before we do that, we need to find out if there are any outliers. So let's see, I had Yami, I don't remember who's in here. Wes, can you help me figure out what is the lower fence for this column A?
Yes. The IQR would be it'd be for the which
95.
column, B or A?
We're doing it for column A right now. So yeah, this is column A, this is column B here.
Okay.
So interquartile range, we figured that out earlier, that was 95.
95.
Okay.
So you go 36 minus 1.5 times 95.
Okay. So do we have any values that are less than negative 106.5?
No.
So we have no lower outliers. Okay. And then just for fun, you want to do the upper one too?
Yep. It'd be 131 plus 106.5, or sorry, plus 95 times 1.5.
Okay, so do I have any values that are less than or that are greater than 273.5?
No.
Upper outliers. All right, so that worked out really well. Let's do the same thing for column B here. Interquartile range is 92. Can you do that, Seth?
Yep, so it'd be 39 minus what's it called? 39 minus 1.5 times. Am I doing that wrong? Sorry.
No, you're doing it right.
Okay, times 92.
Okay. Any values less than negative 99?
No.
Column B. So no lower outliers. And upper.
And then 131 plus 1.5 times 92.
Oh. See, I was hoping that this would be an outlier. So is 246 an outlier?
No.
No, but if I had a 288, would that be an outlier?
Yeah.
Okay, I'm going to make that a 288. So that's going to change my maximum value here, 288. Okay. And so in this case, 288 is an outlier. Okay. All right, now let's talk about how to draw your box and whisker diagram, which is what I was really wanting to do. Okay. So I'm going to draw both of these. Now let's get rid of this. Okay, so as I look at this, I'm going to draw them both here. We're going from basically 10 to 300. So here's what I'm going to do. I'm going to make my scale here 0. Let me make this bigger. Zero, 25, 50, 75. I don't think I'd put us. 100, 125, 150, 175, 200, 225, 250, 275, 300. That's probably good. Okay. All right. So now you can draw these either horizontally or vertically. I'm doing it horizontally, but usually I see them vertically. It's just a little bit easier. So the idea here is now here's the tricky part. Okay. So this is what we're going to call a box and whisker diagram. Okay. And the idea here is what I'm going to first do is I'm going to draw the box. So the box, according to this, is going to be your interquartile range. So your interquartile range goes from 36 to 131. Okay. So what I'm going to do is I'm going to draw a box here from 36, which is roughly about right there, to 131, which is going to be about right there. Okay. So that's your, so this box represents your interquartile range. Okay. IQR. Okay, that's your interquartile range. Now we're going to draw whiskers. The whisker is going to go to 12. And so that's about right to here. That's about 12. And then the other whisker is going to go to 131. Oh, you know what? I did that wrong. No, it's going to go, okay, it's going to go to 147. Sorry, I looked at that wrong. So 147, so that's kind of hard to tell on my scale here, but that's roughly 147. Okay? And then in the middle, I'm going to draw the median, which in this case is 72. 72 is going to be about right here. Okay? So this is what we would call a box and whisker diagram. Okay? So the idea here is that, so this whisker here represents 25% of your data. This inside box here is 25% of your data. This other box here is going to be 25% of your data. And then this very tiny whisker here on the end is 25% of your data. Okay? So the interesting thing as we look at this, you can see here, number one, my whisker on the lower end is much longer than my whisker on the top end, which is kind of interesting. Also, the whisker on the bottom half here, this box here up to the median, is a much smaller box than this here. Okay, so you can see that this data is not symmetric at all. Okay. So this is what we would put as, we'll use this as our column A data. Now what I could do with column B data is I'm going to do the same sort of a thing. And in most cases, this is going to look the same. But I have an outlier on this one. Okay, so that's kind of interesting. So my interquartile range, 39 to 131, this is 136 to 131. So this is probably going to look very, very similar. So I'm going to draw my box for my interquartile range. What was it again? 39 to 131. So 39 is going to be slightly here. Okay. Now I'm going to draw my lower whisker to 12, so that will look the same here. So that's about 12. Now, and also, let's see, my median. Okay, so this one's 89. So this is going to be a little bit higher. So 89 would be probably about right here. And now the question is, do I draw the whisker to the maximum or to the fence? And what I'm going to tell you to do is, if you have an outlier, then only draw it. And there's different rules for this. If you go on the internet, they'll have different rules. But my rule in my class, when you're drawing this, is I want you to draw the whisker to the outlier. Okay? Now, I will say, and I can't remember if the book does this, the book may say draw it just to the largest one. So that might be 147 in this case. But I'm going to say I want you to draw a longer whisker. I want you to draw it to the fence, which is 269. So 269 would be about right there. Okay, so this is going to be a little bit different. And then to signify that 288 is an outlier, you can draw a little asterisk or something at 288. I'm going to just draw a little circle because I don't know how else to do this. And so now you can tell in this case that you've got so data set B has an outlier where data set A does not. Does that make sense? You can also see that this whisker is way longer than this whisker here. So that's kind of interesting. Okay. So this is what we would call a box and whisker diagram. Okay. Now, just for fun, just to compare, Excel does have a box and whisker maker, and you guys don't have to do this, but it's really easy to make box and whisker maker. Boom, theirs is vertical rather than horizontal. And you can see they've got the outlier here. Excel does it a little different. So they did it, they went to the highest number, which is 147 here. And then this 288 is your outlier. Okay. If I were to improve this, I would get rid of this 1. I would probably add my axis titles. I don't know what this data represents. These are just random numbers, I guess. Why won't it let me put that in there? I would still label this. Why won't? Usually there's a green plus right here. There we go, that's the axis title. Okay, so I'd get rid of that 1 because that doesn't mean anything. And I would add in, this is column A, this is column B, that's pretty close. And these are random numbers. And I don't know what this data represents because it's just fake data math 1040 or something like that. Okay. So you can do them either horizontally or vertically. This is actually the way I would be more likely to see them, but you can do them horizontally, and that's just fine as well. So do you guys have any questions for me on box and whiskers or 5-number summaries or anything like that? Okay, so as far as the test question goes on Friday, I'll just say, give me the 5-number summary, give me the box and whisker. And the idea is if you have an outlier, draw it to the fence. If you don't have an outlier, you draw it to the maximum or the minimum. Okay. All right. What else do we have here for? Oh, I had a worksheet. Oh, that's fine. Oh, we don't use this technique anymore. Okay, so now the last thing that I want to talk about is standard deviation. And so, all right. Okay, so the thing that I do want to mention to you guys, I was hoping that I wouldn't have to give you guys. So as far as the test goes on, oh, do I have that up here? Oh, I do. Here's what I'm going to do. These are the formula sheets. I'm going to add this tests and quizzes. I was hoping that I could do one test without the formula sheet, but we're going to need it. And so this can be used for tests and quizzes. And here, I'm going to load this up here right now. I'll make an announcement right here. Okay. So this is an announcement. So here's what I would recommend. You guys can, for the test on Friday, what I want you to do is I want you to print this out. This is a PDF document. Page 1 has all of the formulas you're going to use for the entire semester. What we're going to concentrate on today is the population standard deviation, which is this formula here, and then the sample standard deviation, which is this formula here. The rest of this you're not going to need. We do have information about your interquartile range and your fences here. You're not going to need anything else. Page 2 has a bunch of random numbers. I think I showed you this last time. Page 3, To be honest, you aren't going to need this whole thing. You might as well print it out because you're going to need it by the end of the semester. But all you're really going to need for this test is page 1. And you're not even going to use very much of page 1. You're going to, basically, you're going to need this, and you're going to need this. That's it. But you're welcome to print this out. And this is the only thing you're going to need for the test on Friday. So, so that's available to you. So I would just ask, do not write on this. We're going to reuse this for tests and quizzes. Normally, if we were in a regular class, I would pass this out, but obviously I can't pass it out every time. So print this out before you take your test, because if you print it out during your test, it will kick you out of Proctoria. So just make sure you print that out first. All right. So let me. All right. So this is mean, median. This is 5 summary and box and whisker. Okay, so now let's talk about standard deviation. Okay, so let's say that want to buy 2 potatoes. And so one potato is from an Idaho farm and it weighs 4 ounces and another potato weighs 6 ounces. Let's say that you buy another one and this is from a Las Vegas farm and one potato weighs 1 ounces, the other potato weighs 9 ounces. Okay, so who was the last person I picked on? Yami, did I pick on you a second time? I can't remember.
I've gone second, but it's okay.
Okay, so can you tell me what is the mean size of a potato in Idaho? In your head.
Yeah, it'd be the average.
Okay.
4 plus 6 divided by 2.
Yep, which would be?
7.
No, it would be 5.
Right, 5.
5. And how about over in Las Vegas? What would be the average potato size or the mean potato size in Las Vegas?
5 as well.
It would be 5 as well. So would you agree with the statement that it doesn't matter where you buy your potatoes, they're the same in Idaho as they are in Las Vegas?
Yes.
Do you guys, would you agree with that?
No, they're more consistent size in Idaho.
They're more consistent size in Idaho, right? Okay. The mean's the same. If you just look at the means are exactly the same. But where would you get you'd get your potatoes in Idaho, Wes? Is that right?
Yes, because they're very tasty.
They're very tasty. Now, is there anybody that would rather get their potatoes in Las Vegas? Usually we have some gamblers because you could get a big potato or you could get a really small potato, right? All right. So yeah, so these are for the gamblers. These are the gamblers' potatoes, and these are the people who want consistent potatoes. Okay. All right. So one way to talk about measures of dispersion would be simply to do the range. Okay. So the range equals the maximum minus the minimum. Okay. Now, one of the things on the test on Friday, I don't think that the book does this. So the book would just say, oh, I'm going to do a range of 6 minus 4, which is 2. And I'm going to do 9 minus 1 is 8. But I would like you, when you do this, if you could put 4 to 6 as your range, and you could put, in this case, 1 to 9, because it's nice to have the endpoints in there as part of your range, okay? So when you're doing the homework, it's probably just going to give you the 2 and the 8, but on the test on Friday, I would like you to put the endpoints in as well. I'd like both answers to be here, okay? So, and this is being recorded, so you can't say I didn't tell you, because I'll be like, go watch the video. Okay? All right. So now the thing is, let's add a third potato in here. We'll add a, oh heck, we'll just make them both 5 in this case, okay? So if I add potatoes, a 5-ounce potato in here, these don't really change, and these don't really change as well. But we've added a third potato in here. So the idea here, your range is kind of a quick and dirty measure of dispersion, and it's not very sensitive to changes, especially if you add something in the middle. You'd only have to add something on the end, okay? Plus, this is really much too, well, I won't say it's much too easy of a calculation for this class, but it is pretty easy. And what I'd like to do is I'd like to talk about the standard deviation, okay? And the definition that I'd like to give you, and I know that I told you that I don't like the word average, but I'm going to use it again. Average distance from the mean, okay? All right, so the idea with standard deviation, we've got a new farm, and we've got potatoes that are 1, 2, 3, 4, and 5. Okay, and so let's see who's the next one. I think Wes is next here. Wes, can you tell me what is the mean size of a potato out of these 5 potatoes? Can you do that without thinking too hard?
3.
3, very well done. Okay, it's right there. Okay. Okay, so when we talk about the average distance from the mean, what I'm going to do is I'm going to say, and Wes, since you answered that so quickly, let's talk about the difference. Okay, the difference from 1 to 3 is what?
2.
2. From 2 to 3, the difference is
1.
From 3 to 3, the difference is
0.
4 to 3,
1.
5 to 3,
2.
2. Okay. So what I want you to do, Wes, without thinking too hard, okay? If you were to look at these differences, this is a kind of a fake example, but I want you to think about this, and I want you to guess, what do you think that the average distance of these 5 numbers would be?
1.
So, well, it's probably in between 1 and 2, right?
Yeah.
Because you got 1 and 2 in there twice, and then that one 0. But so one way we could do is we could guess that the difference is about 1.5. Okay, and that's actually a pretty good guess. Okay, so now what I'd like to do is I'd like to bring in these formulas here. Okay, I'm going to copy this, and I'm going to paste it here. So this is, oh, that doesn't say sigma. Okay, so this is your formula for your population standard deviation. Population standard deviation, or actually this is the variance. And I've got another formula here that's very similar. And we're going to use, oh, that's not supposed to say sigma. I need to change that. That's supposed to say S. Didn't even notice that was a mistake on my notes there, but I'm fixing it right now. Okay. So I've got two formulas. This is the population. Sorry, this is the sample variance. Okay. So these are my two, and then the standard deviation is the square root of the variance. Okay. All right. So as we look at this, all right, here's what I'm going to do. Maybe I should copy this. Okay. Now, the idea here is, so we did a guess of, I don't know why, is this going to scrunch me? Did. Okay. Now, we did a guess of 1.5 earlier. Now, the idea here is, in both of these formulas, okay, the first question you have to ask yourself, am I dealing with a population or am I dealing with a sample? So you remember in chapter 8 or 9, I don't remember which one it was, I asked you to distinguish between the population and the sample. Okay, these formulas are very similar, and we'll talk a little bit about what they stand for. Now, this Greek, here, I'm going to copy this. Okay. Oh, it's not letting me do this. Okay, this weird looking E thing, the first letter there, that's the Greek letter sigma. It kind of looks like an E. It's actually the Greek letter S. Okay. X sub I, I'm going to do it this way. X sub I equals your data. Okay. This weird looking letter here, it looks like a U with a tail on the front. That's the Greek letter mu, and that represents the population mean. Okay. And then the capital letter N equals your population sample size. Okay. Now, on this one down here, oh, and by the way, I should also mention here, this letter here is also the Greek letter sigma. So you've got two sigmas in here. This weird looking E thing, that's the capital letter sigma, and this is the lowercase letter sigma in Greek. So these are actually, believe it or not, are the same letter. Okay. So I always like to joke with my students, if it looks Greek to you, it is, because these are Greek letters that we're using. Okay. Now, this second formula, once again, this is the same sigma. Okay, so this sigma, anytime you see the Greek letter sigma with that looks like an E, it means sum. Okay, and in fact, even Bill Gates knows that, and so that's why we have this letter sigma here. Bill Gates knows that anytime you have that capital letter sigma, that means sum. Okay, now, so you'll notice here that these formulas are very similar. We still got xi as my data in the second formula. We still, this time, instead of the Greek letter mu, I have an x with a bar over it. So x bar equals your sample mean. X bar, I didn't do that, equals your sample mean. And n, lowercase n equals your sample size, and then the Greek letter S, sorry, the American letter S is just going to represent S, which is standard deviation. Okay. All right. So I've kind of explained both of those formulas. Now, the idea is which formula to use. Well, you're going to use this top formula if you're dealing with a population, and you're going to use the bottom formula if you're dealing with a sample. Okay? Now, here's what I'm going to say. I will give you these formulas. They're on your formula sheet right here and right here. Okay? Notice I have a square root on here. I don't have the square root here, but we'll talk about that in a minute. Basically, in either case, the standard deviation is the square root of the variance. Okay? Now, so here's what I'm going to say. I'm going to give you these formulas. They're on your formula sheet. I'm also going to give you some steps because I know some of you like to follow steps. These are not going to be on your formula sheet. You're going to have to memorize them if you like to do steps, okay? So the first step, whether you're dealing with a population or a sample, is you're going to find the mean of your data set. Okay? And so in that case, that represents the Greek letter mu or the X bar, okay? In both of these cases, those represent the mean. One's a population mean, one's a sample mean. Step number 2 is you're going to find the data minus your mean. Okay, so in this case, X sub I represents your data, so data minus your mean. Step number 3, you're going to square the difference. Okay, and so that's why we've got, so you've got your data minus your mean, you're going to square the difference. Data minus your mean, you're going to square the difference. Okay. Step number 4, you're going to find the sum of your squares. Okay. And that's what this Greek letter here means, sigma, sigma. So we're finding the sum of all of these differences that are squared. Okay. Step number 5 is to divide by n or n minus 1, depending whether you have population or a sample. And then step number 6, which is not shown on here. Oh, by the way, I should mention this is the variance. Okay. And so we're basically done with these formulas here. But if we want to find the standard deviation, then step number 6 is take the square root to find the standard deviation. Standard deviation. Okay. And we are going to go ahead and do that now. I'm going to slide this over a little bit. Okay. Now, so we did this very simply with Wes a little bit earlier, but now we're going to do the actual steps. Okay. So step number 1, we've already found our mean. Step number 2, we're going to find the data minus the mean. Okay. So that's going to be 1 minus 3. In this case, it's going to be a negative 2. I kind of ignored the negatives with Wes when we did this earlier. But you shouldn't ignore them normally, okay? This is going to be 2 minus 3, which is negative 1. This is going to be 3 minus 3, which is 0. This is going to be 4 minus 3, which is 1. And this is going to be 5 minus 3. Now, I guess I should have said this before I started doing this. Normally I make you guys do this in Excel, but since I'm not doing it in Excel, I still think it's helpful to kind of see this. You guys are going to have to do this on the test. I guarantee you there will be a question on the test that says, here's some data. I want you to find this by hand. And so I want you to go through all of these 6 steps here. This is going to be a test question, I can guarantee it. Okay. So we found the mean, which was 3. We found the data minus the mean, which is column D. Now we're going to square the difference. So I'm going to square the difference. Okay. So I'm going to take this number and I'm going to raise it to the 2nd power. So 2 squared is 4. I'm going to take this number, I'm going to raise it to the 2nd power. 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay, so I've just completed step number 3. I've squared the difference. So I've got your data minus your mean. We've squared it. According to my formula, the next thing I need to do is I need to find the sum. Okay, so I'm going to use this button here which says find the sum of that column, which is, in this case, 10. Okay, so I've just figured out step number 4. So I've figured out my numerator. The sum of my differences squared. Now I have to divide by n, or n minus 1. Okay. Now, in this data set, I didn't try to find out, or I didn't tell you if this data here represented a sample or a population. Okay. I will have to tell you that. Now, the sample variance, this is the more common formula that you're going to use because typically when we're dealing with data, we typically deal with samples. We don't typically deal with the population. So if you're going to guess, this is probably the formula that you will use, the bottom formula, rather than the top. Okay. In this case, I'm going to do it both ways. So if I treat it as a population, I'm going to divide by, in this case, 5. And if I treat it as a sample, I'm going to divide by 4. Okay. So in this case, I'm going to take 10 divided by 5. So this is going to be what we call our population variance. And if I treat it as a sample, I'm going to take 10 and I'm going to divide it by n minus 1, which is 4, which is 2.5. This is your sample variance. Okay, so you can see that step number 5 is where you're really going to have to make sure you understand whether your data is comes from a population or comes from a sample. Okay. Now, the last step is to find the standard deviation, which is simply to take the square root of 2. Now, remember, when we started this, we said that we were guessing 1.5. Wes guessed 1.5. And we're going to see how good of a guesser Wes was. 1.41, that's pretty close, right? If we treat it as a sample, we're going to take the square root of 2.5. Once again, Wes guessed 1.5. He was very close. It's 1.58. Okay, so you can see these numbers in this case, whether you use whether you treat it as a population or a sample, the values are probably going to be very similar, but they'll be slightly different based on whether you treat it as a population or treat it as a sample. And so these are the correct answers. Okay. All right, now I wish I had you all on camera and I would say, how many of you feel super confident that you can ace this on the test? Raise your hand on Friday. Okay. Easton feels pretty good. Okay. All right. This will be the hardest question on the test. Okay. Now I'm like I said, if this was a normal classroom, I would have gone over that really slowly, and I would have told you all to do this in Excel. I'm still going to have you do this. Here we go, range and standard deviation. But what I'd like to do now is I want you guys, we're going to take our random data. Oh, this was it right here. And we are going to figure this out by hand. We'll do one more example. Now, the question is, if this is my data, do you want, since this is just fake data anyway, do you guys want to treat this as a sample or as a population?
Sample.
Okay. So this is some sample data. Now, what I will do here, since we're using the sample, I'm going to copy this over here, and we're going to see how many of you can remember what these steps are. Because you will have this formula for Friday, okay? And so I'm going to see if you guys have this memorized yet. So this is going to be an standard deviation example, okay? So since we picked on Wes, we're going to pick on Seth now. Seth, do you remember, or can you tell just by looking at this, what is the first thing you need to do to calculate your sample standard deviation?
Need to find the mean.
Mean, okay? And how do I find the mean?
You would add up all of these, all the data points, and
I'm all up.
then you divide it by the number of the total points, so it'd be
Okay.
18.
So we're going to divide by 19, okay? So our mean is 80.94737. Now remember, I'm using this spreadsheet on here. You all are going to have to do this with paper and pencil on Friday, okay? All right, so very well done. So step number 1, X bar is the mean. What is step number 2? Since Seth just answered that. You have a question, go ahead, Allie.
For the mean, is there a, like, do you want us to round it to a certain decimal for that?
Oh, that's a good question. You're asking all the good questions today, Allie. Because it actually makes a difference if you round.
Yeah, that's what I'm asking.
So here's what I would say. When you're doing this, because I know you'll be doing this with a calculator, and if you don't have a calculator, yeah, you absolutely have to have a calculator. I would say go ahead and round your mean to 4 decimal places. So 9473, or I guess you could round that to 9474. So that's what I would do. Okay.
Okay, so we do that like right off of the bat, or like every single time we round it to the 4th? So like every single time we have more than 4 decimal points, it's always 4?
Yes.
Okay.
So, and since you asked the question, what's step number 2?
Oh. We have to find we have to square the difference?
Well, first of all, you have to find the difference, right?
Yeah.
So when you guys are doing this on paper, what I would like you guys to do is to put it in a table like this so that I can figure out what you're doing, okay? So in this case, because we're using Excel, I'm going to take the data minus the mean and I'm going to do this little keyboard trick here so that I can copy this formula down. And it's going to copy down, and it's going to use all the digits. So mine's going to be super accurate, okay? All right, so now we just did that. So you have to do that for every single data point. So I've got -68, -65, 56, etc., okay? Now let's go to, did we do Seth? Yeah, we did Seth. Janie, what is the next step based on this formula? What's the next thing you have to do?
So if I'm being honest with you, I am totally lost. So I don't really know what the next step would be.
Okay, so as we're looking at here, remember, so the first step we did was we found the mean, and then as Ali said, we did the data minus the mean, and then I have to do the parentheses. What do I do with the parentheses?
Is it you square the, what's
You're
the
gonna
parentheses?
square the difference, okay? So I'm going to take this and I'm going to raise it to the second power. And I'm glad I picked on you because now you know what you're doing, right? Did you learn something today, Janie?
Yeah.
I've succeeded, yay. All right, so we're going to square. So 68 squared is going to be a very big number, 4,753. That's a very big number. Okay, I'm just going to copy this down. I know it's going to take you all longer. I probably won't make you do this on 19 data points. And I'll try to make this a nicer number rather than that. but no guarantees on the test, okay? All right, so now that Janie has figured out the next step, okay, so looking at this formula, let's see who's next. Easton, you're next. What is the next step? And I'm going to give you a hint. It's this thing. What does that mean?
So you'd add up the column that squared the
So we need to
difference.
find the sum of that column here. So the sum of this column is a really large number, 42,080. Okay. Now, because it's we're dealing with a sample, we're going to do what? Bridger. Is Bridger back? Bridger, you need to get a microphone or something. We can't hear you. And I've already picked on Allie, so it must be Elise's turn. Elise, what is the next step here? I guess this isn't the last step.
Is it 19 minus 1?
Right. So we're going to divide by, in this case, 18. Okay, and so we're going to take this value here, and we're going to divide by 18. And this step has a special name. Well, what was the name of this step, Elise? Do you remember?
I forgot.
It's right there. Begins with a V.
It's, is it variance?
That's the variance. So the variance in this case is 2,337.83. And does Yami, do you remember what the last step is to find the standard deviation?
Yeah, I actually have a quick question. How did we get divided by 18? Like, how did we get 18?
Okay, so look at my formula here. What does N stand for?
The sample size?
Sample size. And so my sample size, if you look at if you count up all those,
19 minus 1.
19.
Oh, okay.
So 19 minus 1 is 18, okay?
Okay.
All right, so what's the last step?
It's the plugging it into the standard deviation. Right?
Yeah, so that's actually, well, if you look at my formula sheet, it's on my formula sheet. What does this thing mean?
Square root.
Square root, okay? So we're going to take the square root of 2,337.83, and that's going to give us 48.35. So this is your final answer here. We'll put that in blue. Okay. All right. So your standard deviation is 48 in this. Okay. Does that make sense? Do you think you can ace this on my test on Friday?
Yes, I was wondering, on the study or like the review sheet for the test, are you gonna have questions like this so we can actually like practice them out and then have the answers later so we can see if we got them right and like which ones then we need to work on? Or is it just gonna be like formulas in the notes and stuff like that?
So typically my formula sheet, let me look at my formula sheet or my review sheet, because I can't remember if it's, I have one here. I can't remember if I included chapter 3. Oh, for some reason that didn't include chapter 8. That's weird. I have to do this again. I think that was right though. So this is typically, I need to adjust this a little bit because we're not going to cover chapter 3 and we did cover chapter 8. So, but typically, this is basically how it's going to look is I'm going to say, do you understand these concepts? And then I usually give you some problems to study.
Will there be answers to those questions so that we can know like how to get to them or like later for us to look over them?
Well, do you know what a categorical variable is?
Yes.
Okay. Do you know what a quantitative variable is?
Yes.
Do you know when you should use
like
these?
Like
I
if
typically
actual
don't.
math parts, if we had parts to like.
Yeah.
practice.
So what I can do, if you would like, I can post some data because I know this is the hardest thing is your standard deviation. I can post some extra problems because I don't think that the homework, they don't make, so sometimes they'll make you go through some of the steps for this, but they won't make you do the whole thing. So I can give you guys some extra practice with the standard deviation. Would you like that?
Yeah, that would be nice.
Okay. Now let me just mention one other thing here about, do you think, and I'm normally when I teach this class, I think it's helpful. I normally make you guys do this in Excel, but I'm not going to do that this semester because it's just a little bit harder. But do you think Excel could figure out the standard deviation by hand or without going through all these steps?
Yes.
Yes. So the nice thing is Excel has a command called stdev .p and .s. What do you think that stands for?
Population or sample.
Exactly correct. Okay, so the idea here is you can just highlight all your data like this, and we're going to find out if we're as smart as a computer. Look at that, 48.3511. See how smart we are. You guys will all be as smart as a computer when I get done with you. Okay, so I will give you guys some extra homework to do, but you have to do the book homework. You don't have to do the extra homework. You don't have to turn in the extra homework. Does that make sense? And I'm pretty sure I have some spreadsheets somewhere. They'll probably be in a spreadsheet format, but you'll need to do this by hand, basically. Does that make sense? Okay. So you can always check your answer. Of course, if you're rounding off your mean, like if I round, so for example, so this is the correct answer, but if I rounded off my mean to, let's just say 80.9, 80.9, the nice thing about the way I've done this, so this is the correct answer right here. You'll see how rounding affects your answer. Oh, wow, it didn't change it that much. I'm really surprised. I thought it would change it more than that. That's the exact same answer. How can that be? Wow, I'm surprised. Those are actually really close. I'm surprised. 81. Okay, that did change it. All right. So I'm surprised. I thought that would change it a little bit more, but I still think you should probably round to 4 digits on your when you're doing this. Okay. All right, so we've got 10 minutes left. I definitely do not want to start chapter 3. Would you guys like to do one more example of this together as a class? Make sure you know what you're doing. Okay, this time we'll do it with a population. Okay, so this is going to be population standard deviation. So problem is coming up with data. So we're going to pretend these are test scores. And we're going to do some random numbers between 61 and 100. So we're going to pretend these are test scores. Actually, there's only 9 of you. So we're going to pretend that these are your test scores for the test on Friday. And so these are your, these are the test scores for summer semester entire class. Okay. So because it's the entire class, we're going to treat this as a population. So I have a blank page here. So that means we're going to use this formula here. And I will post this after class so that you guys can look at it. Okay, so you've got your formula there. I'm just going to let you guys shout it out in any order, and you can tell me what to do, because you'll have this formula on your test.
Find the mean.
Find the mean. Okay. In fact, I will just tell you guys, whenever you have a data set, you should just find the mean no matter what. Okay. So the mean in this case is 77.55. Okay. Second step.
Find the difference.
Find the difference. Okay. So the difference, and I'm going to do this fast because I know we're out of time. So it's going to be this number minus that number. Do my little keyboard shortcut. And we're going to scroll that down. I don't expect you guys to do it this fast, but we're kind of in a hurry. Next step.
Square the difference.
Square the difference. So we're going to take this number, we're going to square it. Okay. Next step.
Sum of the squared difference.
With the sum of the squared differences. Okay. Next step.
Divided by the count.
Divided by the count. Yeah, that's one good way to, and we're doing it by the whole thing because we're treating this as a population. Okay. What is this step called?
The variance.
The population variance. Very good, Elise. And the last step.
Take the square root.
Square root. So the square root of 48 would be, so, okay. So one way to think about this is if these really are your test scores on Friday, we would have a mean test score of about a C+, about a 77.5, and you'd have a standard difference of about 7 points. Okay.
When you say that, the standard difference, I mean the standard deviation, does that mean that generally the test score would be 7 points higher and 7 points lower, or what exactly does that represent?
That is such a good question, and I probably should have brought this up sooner. Okay, so the idea here is, oh, I don't want to erase that. Okay. Now, one of the things that we didn't do, we're gonna pretend, and which is a very bad assumption. I've only got a sample size of 9, or a population size of 9. The two most important things, numbers in a normal distribution, are your mean and your standard deviation. Okay, now the idea here is we're going to have something called the 68, 95, 99.7 rule. Okay, and the idea here is if your data are normally distributed, which we should not make that assumption necessarily with this, but we're going to pretend, God, that's the best normal looking curve I've ever made in my life, I think. I'm getting better at this, okay? So the idea with a normal distribution is this is going to be your population mean, or mu. So in this case, if this was our thing, we would say 77.5 would be the average score, or the mean score, okay? Now, if you go out one standard deviation, so this to here, okay? If your data are normally distributed, you would expect 68% of your data to be within -1 standard deviation, and I'm going to put sigma here, and +1. What happened? +1 sigma. Okay, so if I were to do this here, let me fill this in with, say, red. Okay, so I would expect 68% of my data. Now we just figured out that the data in this, I'm going to round that to 7 to make it easy. Okay, so our score was 77.5. You would expect 68% of the class to be within 70.5, and if I add 7 to that, 84.5. Okay, if the data are normally distributed. Okay, and so that's why we have the 68-95% rule. So 68% within one standard deviation. If I go out 2 standard deviations, let's pick on that color of red, and I'm going to draw another line here. Okay, so here to here, I'm going to fill that in here and here. And so if I go out, I'm going to just abbreviate this as -2s and +2s. Okay. If I go out 2 standard deviations, I'm going to have 95% of the data. So if I subtract 7 again, so that would be 63.5, and add 7, so that would be 91.5. Okay. If my data are normally distributed, I would expect 95% of my data to be between the scores of 63.5 and 91.5. okay? Assuming my data are normally distributed. And then finally, the last number here is 99.7. If I go out here to -3 and +3 standard deviations, so -3 sigma and +3 sigma, then I can fill in the rest of this. And so you would expect 99.7% of your data to be between the scores. If I subtract 7, 63 minus 7 is 56.5, and plus 7, 98.5. Okay. And so we haven't really talked about the normal distribution other than we want our data to be normal. 9 is this is kind of a small data set to determine if your data are normal. So I don't know that we can make that assumption, but obviously in a much larger data set, this is what we would hold to be true. So does that make sense?
Yes, and it makes things a lot clearer.
Okay.
Just from everyday life and having to hear engineers talk about it.
All right. Well, we're way out of time, but I will add my notes up here. I'll post the quiz. Your homework will be due on chapter 2 on Friday. We'll spend about an hour reviewing, and then I'm going to give you guys, most of you I think should finish the test within an hour, but I'll actually give you 90 minutes to finish the test on, so we'll start the test right at, 9 o'clock, or if you don't have that many questions, I'll let you start a little bit early too. So the quiz will be due at 7:55 on Friday. The test will be due at 10:30 on Friday. And so just as a reminder, oh, by the way, I forgot to check. Did the Proctorio work this time?
Yes.
Okay, good. I found out I didn't quite set it up right, so that's good. Okay, is there anybody for whom did not take the Proctorio quiz? 1, 2, 3, 4, 5, 6, 7. We've got 7 people here. That's better than, I think is that our best attendance yet? Okay, so I will assume that you all will ace the test on Friday and you won't have any technical problems. Basically, here's what I will say. Oh, this isn't a good example. But here's what I would say. When you take your picture of your test, okay, here I'm gonna take a picture. Oh, this isn't gonna work. But at any rate, here's what I would recommend. So you're going to take pictures of your test with your cell phone. You're going to insert a picture from this device. I'm just going to find some random pictures. You're going to see whatever I've got in my picture folder here. We're going to pretend that that's my test. So there's your first picture of your test, and then insert your second picture of your test. Whatever, this is your test, okay? So it'll be on So that's page 1, page 2. Maybe you'll have one more page of pictures. Insert picture, whatever. And so then you can save as, you can either save it as an Adobe PDF or you could save it as a doc file. Either way, this probably be a little bit smaller. So you'll save that and then you'll upload that. Yeah, so I guess we need to save it first, okay? I don't know what that is anyway. Oh, whatever. And then you'll upload the PDF or whatever it is, or a Word document. So I know last semester I had a bunch of people that they would save like every picture was a separate file, and I would prefer that you didn't. I would also prefer, please make it landscape if possible, because I don't want to turn my computer sideways to read your test. So, all right. I know I need to let you guys go. Any last questions before I let you guys go?
You said you would rather the orientation of it be in landscape rather than portrait?
I just wanted to make sure that I don't have to turn my computer sideways to read it. So whatever
works to make that work.
Whatever works to make it so that I don't have to turn my computer. Actually, I probably said landscape and I meant portrait.
Gotcha. Okay, I was just making sure.
Yeah, just make it so that I don't have to turn my computer sideways. But anyway, it'll just make my life a little easier. So I have to tell you, grading on my computer takes me so much longer than when it's on a piece of paper. It's ridiculous. So make it clear. This is number 1. This is number 2. This is number 3. The test will be a combination of some multiple choice. The computer will grade those and show your work. You know, you'll have to create a graph. Like the question may say, create a graph, and I'm just going to look at your paper when you do that. So, okay. Any other questions? Okay. Well, I will stop recording. I'll let you guys go. We'll review on Friday for about an hour, and then you guys can take the test. And we'll see you all on Friday. Okay, make me proud. Do awesome. Ace my test.